Mountains have always been symbols of strength. Immovable. Unbreakable. The kind of giants humans were meant to walk around, not through. But today, machines dive straight into their hearts, carving perfect passages through thousands of meters of rock. Inside the darkness, metal teeth grind, hydraulic arms press forward, and sensors track every breath of the mountain. This is where physics, danger, and raw human ambition collide. And no country has pushed this frontier harder than China. In this video, we're going deep into the world of long-distance mountain tunnels. How they're planned, how they're carved, and how thousands of workers and machines stay alive beneath millions of tons of rock. Welcome to Sargani Tech. Behind the scenic beauty of China's mountains lies a harsh truth. For centuries, narrow cliff roads, unstable slopes, and harsh weather have taken lives. Landslides, rockfalls, and snowstorms turned travel into a gamble. Even today, China records over 1,000 deadly landslides every year. So instead of going over the mountains, engineers decided to go through them. Long tunnels cut travel time, reduce accidents, save fuel, and turn dangerous terrain into safe corridors for millions of people. These aren't just shortcuts. They're lifelines that connect remote regions, support trade, and reshape the map of modern China. Before a single rock is touched, engineers spend years studying the mountain. They drill exploratory holes hundreds of meters deep to test hardness, water pressure, porosity, and fault lines. They collect rock cores and run them through labs to predict how the ground will behave. Environmental teams look at everything from soil erosion to underground water flow. Every detail is logged into 3D simulation software that builds a digital model of the mountain. Inside these simulations, engineers test different tunnel routes, slopes, and curvature radiuses until they find the safest and most cost-efficient path. If the mountain is a mystery, this is the part where its secrets are finally revealed. At these depths, air becomes a problem fast. Heat rises, dust hangs in the air, and oxygen drops. So before excavation truly begins, the ventilation network is built. Vertical shafts are drilled from the tunnel up to the surface. Some are 4 to 6 meters wide, others stretch nearly 200 meters high. Their job is simple but vital. Bring in fresh air and push toxic fumes out. Sensors monitor oxygen, temperature, and gas levels in real time. Jet fans kick in whenever the air quality shifts. These shafts act like the lungs of the project, keeping hundreds of workers alive as the tunnel grows deeper into the mountain. Now comes the star of the show, the tunnel boring machine. A machine so massive it's brought to the site piece by piece, carried by dozens of specialized trucks. Some modules weigh hundreds of tons. The cutter head alone can weigh more than 1,500 tons and span nearly 15 meters. Assembly happens deep inside the mountain, under hundreds of industrial lights. Steel frames are reinforced, auxiliary tunnels are widened, and laser systems help align each piece with millimeter accuracy. By the time it's fully assembled, the machine stretches almost 100 meters long. It looks less like a machine and more like a steel skyscraper lying on its side. Once the TBM is activated, the mountain begins to shake. Hydraulic cylinders press the cutter head against the rock with up to 500 tons of force. 20-plus alloy discs spin at high torque, grinding solid rock into fragments. Every drilling cycle advances the machine by a little over a meter and takes about half an hour. This cycle repeats all day, every day, sometimes more than 50 times per shift. Crushed rock is loaded onto conveyor belts and carried out automatically. Cooling jets spray high-pressure water on the cutter head to keep temperatures down. Meanwhile, the rear of the machine installs support structures and forms the circular tunnel lining. It's like watching a rolling factory move through the earth, 1 meter at a time. But not all mountains cooperate. Some layers are too soft, too brittle, or too unstable for a TBM. Even a small vibration can cause a collapse. This is where engineers switch to controlled drilling and blasting. Hundreds of holes are drilled in precise patterns. Explosives are inserted, each with calculated timing. When detonated, the blast breaks the rock exactly along the planned direction. Heavy ventilation removes gas and dust before workers re-enter. They inspect cracks, clear debris, and spray a temporary concrete layer to stabilize the roof. It's slow. It's delicate. But in the wrong geology, it's the only safe way to move forward. As challenges grew, tunneling needed a smarter approach. Enter the sequential excavation method, or NATM. Instead of resisting nature with heavy reinforcements, NATM works with the mountain's natural strength. Engineers remove only a small piece at a time, then immediately stabilize it with sprayed concrete, steel mesh, and rock bolts. The surrounding rock becomes part of the tunnel structure, forming a natural arch. This method reduces reinforcement materials by up to 40% and keeps vibrations low, perfect for tunnels built under towns or near sensitive infrastructure. Real-time sensors watch every movement of the rock, sending data to the control room. If even a tiny shift is detected, the excavation strategy is adjusted instantly. Once the tunnel breaks through, the hard work isn't over. Engineers run high-frequency ultrasound, ground-penetrating radar, and optical cameras to check every bolt, seal, and surface. Ventilation systems, smoke detectors, jet fans, drainage pumps, and backup power units are tested again and again until the tunnel meets international safety standards. Only when every reading looks perfect does the tunnel open. Even after opening, the tunnel is constantly monitored. More than 1,000 sensors are embedded in long tunnels. They track humidity, vibration, pressure, water leakage, and structural movement 24 hours a day. Maintenance teams inspect fans, cameras, lighting, fire alarms, and pumps on fixed schedules, usually at night when traffic is low. Drainage channels are cleared. Emergency systems are tested. Nothing is left to chance. A tunnel may take years to build, but it stays alive for decades. Every mountain tunnel is more than concrete and steel. It's the result of thousands of decisions, simulations, sleepless nights, and the courage to challenge nature itself. China's 22,000-meter tunnels represent what happens when engineering, technology, and determination work together. If you enjoy learning how our world is built piece by piece, subscribe to Sargani Tech. There's a lot more to explore.